With support for up to 8 GPUs, 8 CXL memory expansion devices, 8 AI accelerators, or whatever the heck else you want to put in this system is absolutely awesome. What's more, because this is using the AMD EPYC 9000 series, we get a ton of cores, lots of memory, and a much simpler design than many other AI systems out there. We got a lot to talk about, so let's get to it. Hey guys, this is Patrick from STH, and this is the ASRock Rack 4U HG Turin 2. This system feels like a throwback because we first tested an 8 GPU ASRock Rack system in September of 2015. And so, of course, like always, we're gonna go tear apart the system and I'm gonna show you all of the really cool things you can do. But before we get to that, I just wanna say thank you to ASRock Rack for sending the system, AMD for sending the CPUs. I think we had Kioxia with SSDs. We had some GPUs from NVIDIA and elsewhere. We also had CXL from Astera Labs. Probably forgetting some folks here, but of course it takes a village to make these kind of videos. And that village includes the STH YouTube members who have joined down below to help us go and buy memory. So of course, we have to say this video is sponsored, but let's get to the hardware. Okay, now the first thing you're gonna notice is that on the front of this system, we have 24 drive bays. Now, these 24 drive bays are in two different sets. The first set is these first 4 drive bays, which are NVMe, so PCIe Gen 5 by 4 NVMe drive bays. Now, the additional 20 drive bays, you can optionally set up as, SAS, SATA, whatever, depending on how you have the rest of the system set up. So if you want to go configure those as NVMe or SAS or whatever, you can go do that. Instead, let's take a look real quick at one of these drive bays. Because what you can do is take your drive, we're going to use a Kioxia drive here, and you just line these things up, you pop them in place, and now you've already got your drive bay and you're ready to go install it. Boom. Now these 4 drive bays are really for that local storage, really that storage that you want it to go fast because it's in the system. Of course, most of these servers also have high-speed networking to larger storage arrays than you'd ever get in something like this, and also that you would share among the rest of the cluster. Okay, now underneath the drive bays, we have these expansion card slots, but they're a little bit different than you might expect. The first thing is they're on the front of the system, not on the back. The next thing is that you see on either side, we have these full height expansion card slots. And those are a little different because actually the one that's on this side is not hooked up in our system. Instead, it's the one on the opposite side that has a PCIe Gen 5 by 8 connection. Now the center one is a little bit different. The center one is an OCP NIC 3.0 slot, but it's a PCIe Gen 5 by 8 slot. Now, of course, these things are all configurable because we have the ability to go and take, say, the 8 lanes that are going into the slot on this side. You can just move the cable from this connection into the center one, and your OCP NIC is all of a sudden a by 16 connection. The nice thing is because these are all MCIO cables, it's really easy to reconfigure this, and ASRock Rack gives you all the different mounting points, so however you want to configure it, you can. Okay, now on the bottom over here, we have what is definitely a little bit of ASRock Rack flavor. Every single ASRock Rack system that we've ever reviewed for probably the last decade or so has something that's just a little bit neat and just kind of that their engineers just thought up and just kind of cool. And that's really what we're seeing on the front here. Now we have 4 USB 3 ports, which of course are always useful if you have to go and do local KVM. In fact, even just having the front IO is important because this system uses so much power and generates so much heat that it's oftentimes, especially with GPU servers, just way better to be in front than in the rear of the system. Next to that, you're gonna see a couple of other things that you'd use. Like for example, you have a VGA port. A lot of folks ask, can a system like this play Crysis? And depending on what kind of GPU you have in the back, you may not actually have any HDMI or DisplayPort outputs. Instead, you may still have a little VGA port driven by what's essentially Matrox graphics from the late 1990s. Next to that, we have our power button, because of course you need that. And then we have this little part right here. Now, this part is perhaps one of the craziest little features because what ASRock Rack does is they route the Ethernet connections for things like the out-of-band management, but also the 2 Ethernet ports, which are Intel i350 based 1 gig ports. And then you'll see that we have these cables. These cables are literally just Ethernet cables that go all the way from the front of the system through the chassis and to the rear. So we get to the rear of the system, you're gonna see these Ethernet ports that are powered by just literally saying, okay, I'm gonna go and get my rear IO by plugging these cables in. We've seen this on other ASRock Rack systems, and I just think it's just one of the more fun things that they do. Okay, now looking at the rear of the system, there are essentially 3 things that matter. The first thing is that we have a bunch of I/O expansion slots. So you can see these right here, and these expansion slots are really where we put our GPUs and other accelerators. The next part is that on the bottom we have our power supplies, and then we have our rear I/O. So let's go through all three of those. So we're gonna talk more about this top area where you go put all of the GPUs in a little bit, but these are your standard full height expansion slot brackets. There's nothing really fancy to them other than the fact that, well, they're in a server like this. We've seen generations of servers with a similar design, and this is just the new fast PCIe Gen 5 one. Now, the other interesting part of this is you'll see that these two sides are actually being blocked off from airflow, so that way the airflow gets directed through the GPUs. Now the back will look different depending on what you have plugged in here. We are really focusing more on GPUs today, but you could also have, I don't know, like CXL type memory things or storage things back here. In fact, you could go and fill this up with a whole bunch of like external HBAs if you really wanted to and build a giant storage system out of this. I don't know why you would, but you could. You could also have a whole bunch of networking back here. I mean, there are plenty of different options. Now below that, we have our power supplies. So we have a pretty early system, frankly. And so because we have such an early system, these are only 2 kilowatt 80 plus platinum power supplies. But on the spec page on the actual website for ASRock Rack, they say that these are gonna end up being titanium level 2.7 kilowatt power supplies. Of course, if you're gonna get the system later, I would double check what you're gonna get. But the nice thing is that these are all common power supply form factors. So you can go and swap these things out and get different, power configurations based on whatever you need. Now, if you are a glutton for punishment and you just wanna be behind a really, really hot, I don't know, server that's just generating tons of heat and blasting it in your face, you can also get your little KVM cart and go hook it up to the rear of the system. That is what this rear I/O block is for. You're gonna see that we have USB ports, also our VGA ports, so you can do video out of the back. And then we have 3 network ports. Now these 3 network ports are similar to what we saw on the front because we have an out-of-band management port along with 2 1 gig Ethernet ports from that Intel i350. With those pluggable, just kind of little cables that go through here, you can actually pick, you can say hey, I want my out-of-band management to come out of the back, but I want my 1 gig ports that are used for data and really that management of the overall system, I want those to come out of the front, and you can actually just pick based on what you plug in on the front side. It's kind of just a little ASRock Rack, cool little engineering feature. And of course, with that, I think what everybody wants to see is what's inside the system, so let's get to that next. Okay, so starting with this server inside, we actually propped this up just so we can kind of go through it easily from front to rear. So this front part, this top part is really designed for that storage. You'll see that we have the storage backplane just behind that, and you can see that we have our 2 MCIO connectors, and those 2 MCIO connectors and cables are really there for those 4 NVMe bays. Now you'll see on the back that we have headers for SATA and for adding other NVMe drives. We just are not using that in the system. Now below that, you'll see that we have the hardware for the expansion slots that are in the front middle of the chassis, including that OCP NIC 3.0 slot. Below that though is really the motherboard, and we have 2 M.2 slots. So these are the 2 M.2 slots, and these are there for your boot drives. You can have either SATA or you can have PCIe Gen 3x4. You can mirror them, and that's kind of how you do your boot storage on here. The only challenge is that because these are so far in that system, they're actually pretty hard to get to. Now on the processor side, we get some awesome processors because we get 2 AMD EPYC 9000 series processors. Now, you can use a number of different ones. You can use Genoa. I think you can use Genoa X. You can use Bergamo, so up to 128 Zen 4 cores, or you can use the new 9005 series, and that 9005 series is called Turin. There's also a Turin Dense that goes up to 128 full P cores, but you can also go up to 192 of the reduced cache cores, but of course you get way more cores. So from the Zen 5 perspective, you can get all the way up to 192 cores, 2 sockets, 384 cores, 768 threads, and you also get a bunch of memory because each of those CPU sockets gets a full set of 12 DIMMs for our full set of 1 DIMM per channel configuration. Now I know what you're thinking. Patrick, can't the EPYC 9004, 9005 series support up to 24 DIMMs? Yes, it totally can, but the challenge with that is that because 24 DIMMs are so wide, it uses about this much of the chassis width for a single CPU. If you have 24 DIMMs per CPU. So that means that you end up having to offset the DIMMs in the CPU sockets, which means that you're essentially adding like, this whole part, you're adding like another section, which means that your server is way longer. So that's typically why we see only 12 DIMMs or 1 DIMM per channel, because you're still filling the memory channels, you're still getting that maximum memory bandwidth, but you don't also have to do the funky things that you would if you put more DIMM slots on there. Now, installing the CPU is very straightforward, and it's actually pretty easy to get to. We saw some older generation systems where it was kind of hard to get to the CPUs, but this is pretty easy on a relative scale. Also, here's the heatsink unit, and those just plop onto the CPUs once they're installed. Now, in this mid-plane area, we have our fans, and these fans are super easy just to go and pull out. You can swap them if you need to, but these are very heavy-duty fan units, and the reason that they have to be so heavy-duty is that not only are they taking air from the NVMe SSDs over here, but also a little bit from the exhaust from the CPUs, but they then have to go and cool this entire portion where we have all of our GPUs that we'll show you in a sec. Okay, so the first thing to understand when we get to that accelerator area is really what ASRock Rack is doing in terms of connections and connectivity. Because what the company is doing is they have a bunch of different MCIO by 8 connectors. So each one of these takes PCIe Gen 5 by 8 signals and takes these and brings them to wherever you need to go. You could go to the board where we have all of our IO expansion in the back, but you could also, in theory, go all the way to the front and do things like have NVMe drives or whatever you want to go do, other expansion. And so this whole thing here is sitting at the bottom of this chassis, and we've seen it in some other ASRock Rack designs before. And so why this matters and why this system is very unique is because we have all of those MCIO connectors going directly into the boards that are feeding these PCIe Gen 5 by 16 slots. What that practically means is that we don't need extra switch chips. Instead, we can just go directly from the GPUs into the CPUs. This system is taking advantage of the new AMD EPYC processors and all of the PCIe lanes that you have because you don't need those extra switch chips. It saves on cost, saves on power, and that's really the reason you see that. Now, one thing that we found when we started taking this apart was that there's actually a hidden little feature. So underneath the 2 airflow guides, and these are really there, again, to direct airflow through the hotter accelerators in the middle and really block off the slots that are not being used. But if you look at what we have here, you're gonna see something really fun. We actually have extra slots both on top and bottom that are under these airflow guides, and those are not connected. So you can see the MCIO connectors. Those MCIO connectors are not populated here. Instead, they're just kind of empty without cables like all of the rest of them. And what that means is they're not getting any PCIe connectivity. On the other hand, if you did have a case where maybe you had by 8 accelerators or a couple by 8, a couple by 16, you can actually go and remove the MCIO connector, put it into the other slot and activate these slots and start using them. So you can actually add another 2 slots in the system that they don't really even advertise. Now let's tilt the system over and let me show you what it looks like when we install different types of accelerators, including GPUs, into the back of this system. But let's talk a little bit about what we can plug in here, because I think that's important. It's also something that ASRock Rack has spent a lot of time thinking about, and it's something that also just in the industry, I really think that these things have become very mature on. So the first thing you might want to do is you might want to put a NIC in here, and it used to be very common that we would see the network cards, we'd see maybe 8 to 10 GPUs and 1 or 2 network cards in systems like this. But what you'll see here is that we can put this NVIDIA Bluefield 3 DPU in here, and we have a little bit of extra space, so we might want to block that off. But overall, we have a easy way to go put a full height, very large card. But let's say you want to do something crazy. Like let's say you wanted to have it DPUs and have those across the whole thing. You, I guess, could do that. Now, another possibility is that you might have an FPGA or maybe at some point a CXL thing. Now, of course, anything that you do with CXL, I would definitely go and make sure that like I would call ASRock Rack and say like, hey, we're thinking of doing CXL. Can we do this? But just kind of give you an idea of something that could be possible in the future is you could take something like this Astera Labs Aurora 1000 or A1000 part, but you can go plug these things in, and by doing this, you actually end up with more memory capacity and bandwidth over just having the CPUs themselves. So we talk about this in the context of being a GPU server, but whether this is a CXL product or a FPGA, an AI accelerator, whatever it is, there are a whole bunch of large cards that are dual width that fit into a form factor like this, and you just kind of customize in this type of platform. Now, the other big one is that when it comes to GPUs, the GPUs are not all the same. And let me give you an example. Like this right here is an NVIDIA RTX 6000 ADA, which currently, as we're filming this, is like the highest end GPU you can get. So you can go and you can plug this in to the slot really easily, boom. Now you have access to the rear video ports. Now, typically you don't put, you wouldn't have any monitors or something on this, but in some VDI setups, people actually use dummy, DisplayPort or HDMI port things on the back of this. So every once in a while you'll see that, and that's a reason to have access to them. And then the other thing to keep in mind is that you need to power these GPUs. So ASRock Rack doesn't just have the new 12-pin variation, but they also have other ones. So if you have things that are more, the kind of consumer style connectors or whatever, they have different types of cables that can be installed. And you might think that's only for consumer GPUs and even things like this, which is like a high-end workstation GPU, but that's not necessarily the case, because you'll see just a generation ago, we had the NVIDIA A40, which was a passively cooled card, not active, where you have a fan like this, and you can put that in here, but the challenge would be, of course, that you need to have a different power connector, and that's exactly when you would go and use one of these other cables. You just have to go and plug them in. The other thing that you can do, which is just kind of fun, is that you could mix and match. So you could have an A40, you can have an RTX 6000 ADA, you can have an L40S, maybe you want an H100. Hey, who knows, maybe you want to go and have a NIC or two in there. Whatever you want to go do, this kind of provides you a lot of flexibility, which is always nice. Okay, so let's talk really quickly about the performance, because whenever you look at systems, especially GPU systems, what you're really looking for is, do you have the capability to cool all of the GPUs or whatever you need to go put in a system like this without losing performance because the chips that are back there are throttling? That's really what this is all about. So just in terms of what we tried in here, we tried the old NVIDIA A40, we tried the L40S, the RTX 6000 ADA, we had the NVIDIA H100 NVL, we had the NVIDIA RTX A6000, not the 6000 ADA, we had both of those actually. We also tried things like network cards like the NVIDIA Bluefield 3 DPU, as well as some CXL components. So across all of these devices, we managed to cool the cards no problem, with one major caveat. If you do have empty spaces, you have to blank and block the airflow. So that way airflow goes through the passive heat sinks. Now, if you have the active units, it's actually not as much of an issue, but if you do have passive GPUs like that A40, the H100, all those, then you do need to make sure that you're blanking these out. The other big one on performance though is if you are doing peer-to-peer transfers, that's gonna be one that's gonna be a little bit more challenging on a platform like this. And the reason for that is pretty simple. In a topology of an AI server, you often have these PCIe switches. Peer-to-peer transfers over PCIe switches are still a common thing, although the architectures in terms of how these are implemented are a little different these days. But it's also one of those ones where there are applications that just kind of assume that you would be doing that. And so if you do go all the way through the CPUs, like you do here on the AMD EPYC side, then you're, instead of going through a PCIe switch, you're going through the AMD EPYC IO die, and that's just a little bit different. And the other one goes beyond just GPU to GPU peer-to-peer. Some of the reference architectures these days assume that you have like a NIC or multiple NICs on these PCIe switches, maybe storage, all that kind of stuff. And so removing the PCIe switches from the system has the benefit of you don't have that little bit of latency on the PCIe path back to the CPU. You also have lower cost, lower power consumption, all of that kind of stuff. And both from the CPU perspective all the way to 500 watts for those like really high-end Turin parts, as well as from the GPU perspective, we saw great cooling and just the normal performance that we would expect in a system like this. Now, in terms of power consumption and noise, let's just start with noise because it's the easy one. These systems are super loud. You don't want to be on the hot aisle side. You want to be servicing them from the cold aisle side if at all possible. And if you are on the hot aisle side, of course, always wear ear protection, but always do that in data centers anyway. Now on the power side, you'll notice that we only had these 2 kilowatt 80 plus platinum power supplies. So when you have 2.7 kilowatt titanium units, of course, you have more headroom. When you do go and fire this thing up, when you have 8 600 watt devices in the back, that's 4.8 kilowatts. Plus you're gonna have up to say 1 kilowatt from 2 500 watt CPUs, another, call it 180, 200 watts or so of memory, plus a couple SSDs. I mean, you are easily talking about a 6 kilowatt plus system here. And so on top of that, say 6 kilowatts for components, you're also gonna have another 15 to 20% for cooling. And that kind of gives you the reason that you need those 2.7 kilowatt power supplies, not the 2 kilowatt ones that we have here, if you wanna maintain redundancy. With that though, let's get to our key lessons learned. Okay, now in all of these videos, I like to have key lessons learned. And in this, aside from the just cool ASRock Rack engineering that's always present, I think that the big takeaway is really just the flexibility. I mean, we are entering an era where, not only do we have really high power AI accelerators and GPUs and all that kind of stuff, but there's also a whole class of devices that are going to have to be lower power. And that's just because 1000 plus watt accelerators are just not going to be for everyone, right? So we have to have devices that are lower power. And when we do that, these types of platforms become really powerful. And the other thing to remember is that there are AI accelerators and GPUs from NVIDIA, AMD, and others that have bridges that sit atop of all of the PCIe cards. And when you have those like NVL bridges or Infinity Fabric bridges or whatever, that's one of those things that gets you around needing to have those PCIe switches in a lot of cases. And so because you can do GPU to GPU communication without that PCIe switch, removing that PCIe switch just removes another, unit of complexity, more cost, more power consumption, all that, and it just removes it from the system. And maybe that's just a long way to say, I think that a solution like this, the flexibility it offers, is just super cool. And I'd love to hear what you guys think, so let me know in the comments. Of course, we are gonna have a whole bunch of different types of servers, from small servers to giant servers and huge AI servers in the future. But I just like to look at this because I think this is one of those ones that, we've been reviewing for like a decade. So that kind of tells you that this type of platform probably has some pretty good staying power. With that, if you did like this video, well, why don't you share it with your friends and colleagues, but also give it a like, click subscribe, and turn on those notifications so you can see whenever we come out with great new videos. As always, thanks for watching. Have an awesome day.